So after learning about units, we know that a number means nothing without a unit. Okay. The unit is really important in values. So, uh, yeah, otherwise they're just numbers, which means practically nothing. So, but in the world of physics, we have two main types of values. That's what we're going to learn. So, type 1 is basically uh, what we were always reading. Values with a unit, with units. Okay. For instance, $2, 3 kilometers, 10 cents, 5 books, or 20 dogs. They are just values with units. We call this type of values the scalar. We call them scalar quantities or scalar measurements. They're just values with units. Down. That's it. Now, there's another type of value. We call it the vector. We call it the vector quantities or vector measurements. It's basically similar, but they are very similar. They are values with units, also with let's say plus a direction. Okay, so I gave you an example. Say if I'm talking about distance, a distance is a scalar. I'll give you some examples here. So maybe say 20 meters, 40 meters. So it's just a number with a unit, with a distance units. Or 40 meters. However, when we're talking about direction, when we add a direction, say 40 meters east, it becomes a vector quantity and we call them displacement. Okay, yeah, let me give you an example. Say if I'm standing right here, okay, on the ground, and there is, say, yep, let me draw a dog. Yep, this is a dog. Okay. Now, the distance between the dog and me, that's me, yep, is 2 meters. This is the distance. However, if I'm going to talk about the displacement, I may say, well, if someone asks me, where is the dog? The dog is 2 meters at 2 meter right to me. So that's basically a displacement. Because it has a value, it has a unit, and also with a direction. Okay, 2 meter right. So, yep, that's one example. The other example the other scalar quantity you should know would be speed. Okay. Say when I'm driving my car, it would be like 20 meters, about 40 kilometers per hour, or 60 kilometers per hour. The speeding limit is 80 meters per hour on Springvale Road. So, however, if I add a direction to it, say I'm driving my car at 60 meters per hour east or north, okay, we call it velocity. Okay, so yep. Yep. The idea is displacement and velocity. They seem like a fancy word, but they're nothing more than, well, they just they're similar to distance and speed with a direction because they're vector quantities. Okay. Yep. Let me give you another example of uh, displacement and distance. So assume if if there's a dog. Yep, I just like drawing dogs. Yeah, this is a dog. And he, he wants to go to, say, this point, okay, point A, because there's a biscuit or there's something there. So what he tries to do normally, he would try to let's say he start traveling north. He starts traveling a curve shape like this, back and forward, okay, then finally towards the point, and the path he traveled is, say, 100 meters. Okay. However, the direct distance between his starting point and point A would be just 10 meters. Okay. So what we can say is, the dog traveled a distance of 100 meters because that's how much it traveled, and covers a displacement of 10 meters east. That's the difference between displacement and that's the other difference between displacement and distance. Distance is actually the path the dog traveled. The displacement is basically the shortest distance plus direction from the initial point to the final point. We will do more practice on this. Okay, now let me do some simple calculations of vectors. Okay, so the special thing about vectors, okay, they can be presented as a value, say value, units, and direction, say 30 meters per second east. Okay, or it can be presented graphically. So for instance, 30 meters east can be presented something like this. Okay, 30 meters per second this direction. Then if I plus 40 meters per second south, it can be something like this, plus 40 meters per second south. Okay. Then if I want to find the result of 30 meters per second east plus 40 meters per second south. Remember, that's the initial point here. Traveled 30 meters per second east, 40 meters per second south. So as a result, it travels this direction meter per second. It can be represented graphically, and the way you can find it is using Pythagoras theory. Okay. So we have a right angle triangle. Pythagoras theory is 30 meters plus 40 meters, square root of it is going to be 50 meters per second. So this part must be 50 meters per second. And southeast. So, yep. So, yep. Yeah, this is vectors. Okay. Well, let me give you another example. Say if I have this vector, 30 meters east. Okay. So I call this. Okay. I call this. Yeah. This is a vector 30 meters east. So if I want to halve this vector, what I can do is I get the arrow. Well, the length of the arrow indicates the value, and the direction of the arrow indicates the direction. So if I want to halve this vector, I call this vector A. A is 30 meters east. So if I want to write down, give a graphical presentation of half A, it would be just half the length of the arrow and in the same direction. If you do the math, it will be 15 meters east. Okay. And yep. Also, the most beautiful thing about the vectors is we can add a minus sign to it. So if I have minus A, it will be 30 meters to west. Okay, so it's going to the opposite direction with 30 meters west. So if you double it, the arrow will be doubled. The length of the arrow will be doubled. So, yep. Yep, this is some calculation of vectors. Let's just be aware.